The use of water dispensers is rapidly growing due to other studies validating its sustainability efforts and preventing the use of packaged water bottles. Schools and universities are some of the most common places in which water filling stations have been adopted into their libraries and hallways. Despite its sustainability efforts, little studies have been conducted on the effectiveness of these water filters in filtering out water contaminations from the water, such as lead, copper, and bacteria. The studies have been done on water quality show that there could be problems in water quality, especially for the growth of bacteria. Furthermore, the health impacts from contaminated water sources have led to disease and poisoning in the body. Therefore, it is imperative that drinking water is not contaminated. This research study focuses on the water filling stations at the University of Florida, specifically the Rights Union, Newell Hall, Marston Library, Library West, and Southwest Rec, and Norman Hall. These places were decided because of the frequent number of students in these areas. The goal of the study is to determine if there is significant water contamination by using water testing kits. For our hypothesis, the location around the University of Florida campus all varied in foot traffic, availability, and proximity in restrooms. The expected results were dependent on all these factors. We expected the water filling stations that were closer to the bathroom to have more contaminated water. Several buildings, including Library West and Southwest Rec, are open 24 hours, which we expected to have worse water contamination.
To carry out this experiment, we decided to implement methods we found in our literature review and modifying it slightly since we were looking for different objectives from our experiment. Before we describe our methods, we decided to pick these 6 locations because of their frequent visits to these places, meaning the possibility of people using these water filling stations. The 6 locations were the Rights Union, Marston, Library West, Southwest Rec, Newell Hall, and Norman Hall. Drinking water from the water filling stations were collected in sterile sample bottles with sodium thiosulfate, using aseptic techniques to avoid contamination. We decided that we will wash our hands with soap before applying the water. Water testing kits were used to examine if the water sample was presented with fecal coliform, such as E. coli. Hydrogen sulfide kits were used due to its inexpensive cost. They were less than 50 cents per kit, and evaluates if the water sample is presented with E. coli, since the bacteria can produce hydrogen sulfide gas. In addition to fecal coliform tests, the kits that were also bought also can test for minerals and organic chemicals in the water sample. The researchers also tested for certain minerals in the water, such as magnesium, zinc, iron, and copper. After collecting the water samples were tested by using a strip that indicated the presence of the specified substance that we were testing. Once the strip is dipped in the water sample, after a few seconds, the strip would change color, which would determine if the specified substance is presented in the water sample. The pH was also tested for the water. In this case, a strip is dipped into water and the specified color relates to the pH of the water, resulting from a pH of 1 to 14. All of these were qualitative tests that would have been conducted, but some of these tests could produce quantitative data, such as the pH of the water. From these data, we can determine if the water quality of these respective locations are safe to drink.
For our results, we looked at several different studies that tested the water quality of water fountains and water bottle filter stations. The first study was done by the Spectrum, in which they tested 94 out of 245 water fountains at the University of Buffalo. The results came back stating that most of the water contained hard minerals, which is not a health hazard. However, 7 fountains tested poorly for alkalinity, and 49 fountains had a pH level below the EPA recommended level. 7 fountains contained trace amounts of chlorine, and the fountains were also tested for iron, nitrates, nitrites, lead, and copper, and they all came back negative. These results did not necessarily mean that the water was unsafe to drink. This was comparable to the water filter stations on campus. The color status on the water fountains indicated how clean the water was, and the study shows that there was not much of a difference between the water fountains. In a different study done by Rosella Sanchetti, she tested for E. coli, enterococci, total coliforms, Staphylococcus aureus, and heterotrophic plate counts in tap water and microfiltered water. These results showed that both samples did not have any E. coli or enterococci. However, there were coliforms in 5 of the samples tested from the microfiltered water dispensers. The last study tested heterotrophic bacteria commonly found in water supplies where there is inadequate disinfection. The study tested the water bottle filters commonly used in water bottle refill stations and compared those to tap water. Filters used in water bottle stations often use carbon filters, which can act as a food source for heterotrophic bacteria. When they compared the heterotrophic plate counts, they found that the HBC levels in water bottle refill stations were found at 95 CFU per milliliter, while mean HBC levels in tap water were at 55 CFU per milliliter. When the data was analyzed, the mean levels between the 2 water samples were found to be statistically different.
Based on the results of the studies we have examined, we can assume that the water bottle filters found on the University of Florida's campus may have alkaline water, contain high HPC levels, and have total coliforms. It is also likely that the fountains on the campus would possibly have contained fecal coliforms. The results of the studies we examined do not support the presence of fecal coliforms, but it is known that the rags used to clean the bathrooms can also sometimes be used to clean the water fountains and may not be cleaned between the uses. However, this would only apply to fountains that are placed right outside bathrooms, which would make it likely that that is only in places like Marston and the rec centers. It was also found that there is hardly a difference between having a red light and a green light as the filter status, which would mean that all of the filters on campus are safe to drink no matter the status. So while we could not directly test the water and the quality of the filters on campus, we can conclude that the water bottle filters on campus are safe for consumption.